Hello, this is Leon from Enjoyable Maths, and I'm going to show you a test for this formula using a complex number squared, which I think we can do in our head. I certainly can, and if you're watching this, you probably can as well. So this is the formula. I've shown where this comes from in a previous video, and this is for a plus bi to the power of c plus di. Lighting's not very good. I'll see if I can move around to fix that. And let's use the example 4 plus 3i squared. Right, we can do this in our head. That's 7 plus 24i. Yeah, I got that. And in this case, a is 4, so I'll just write to the side. A equals to 4, b equals to 3 because that's the I in the base, c is 2 because that's the real part in the base, and d is 0 because there's no I in the exponent, the c in the exponent, not the base. So let's plug it in and see what happens. So we have the absolute value of 4 plus 3i squared, because that's c, times e to the ln absolute value of 4 plus 3i times d. I forgot to write that before, but that is times di. You can see that I put that in my video, and d is 0, so we'll put times 0, and that will be 1 because e to the 0 is 1, times e to the I2 theta, and I'll write this as e to the I theta squared, because it's easier to do e to the I theta rather than 2 theta, because then you'll have to do trigonometric double angle formula, which no point doing that in this video. And then we have e to the negative 0, which of course this is 1, so these cancel, and let's work out this for a bit. Now, what's the absolute value of 4 plus 3i? Well, we'll draw down here a complex plane, and here we'll have the real axis and the imaginary axis. And let's say this is 3, this is 4, and this, the hypotenuse here, is the absolute value, and 4 squared is 16 plus 3 squared is 9, they are 25, square root of 25 is 5, so that's 5, and absolute value, so the absolute value of this is equal to 5. 5 squared is 25. And here we have e to the I theta squared, and theta, that's this angle here. So I'm going to say, as we know from trig class, sine of theta is equal to the opposite over the hypotenuse, which in this case, 3 over 5. Take the inverse sine of both sides, we get theta is equal to the inverse sine of 3 over 5. Now we can plug this in, and using Euler's formula, e to the I theta is cosine theta plus I sine theta, we get cosine of inverse sine of 3 over 5 plus I sine of the inverse sine of 3 over 5. Now sine and inverse sine cancel, and we're left with cosine sine of 3 over 5. And here, what's inverse sine of 3 over 5? Well, that's just theta, right? This theta. And what's cosine of theta? That's adjacent over hypotenuse. So that's just 4 over 5 plus I 3 over 5. But we do have the squared, we can't forget that. So let's square this, and the real part, I'll work that out first. That's 16 over 25, and that's 9 over 25 negative, so that's 7 over 25 plus I 9 over 25. No, that's not right, because it's that times that, and then times 2, so that's 24 over 25. I don't know what I was doing there, but let's plug this back in. That's 25 times 7 over 25 plus I 24 over 25. Now, you see, this just works out. The 25s cancel, and we're left with 7 plus 24i, which is what we got up here from squaring this out. So yeah, this is proof that it works for a complex space with a real exponent.